Yes, okay. I keep it short because we are waiting for the coffee, I think. So my question is Chisel ready for class? And yes. And I cannot give you the answer. That's actually a question I ask myself, a question I might ask you. Maybe you can help me to give the answer. So as I search for the answer, maybe I can tell you next CCC if it's ready. And I will try out next semester, starting Thursday next week. First Chisel code. Yes, and if you have ideas or questions during my presentations, I'm happy to hear them. So the question is, whom is Chisel targeting at all? Is it targeting hardware designers who know Verilog, VHDL, and currently using TCL, Python, or whatever ARCHI scripting language to generate code? I used Java before to generate VHDL code. Or is anyone really using system Verilog? Or is it targeting software engineers who know Java, C#? Maybe it's relatively easy to step up to Scala when you're starting out from Java. But hardware is so different from software. I mean, you still need to learn this mindset on circuits and synchronous processes and all this stuff. But maybe we need to move the software engineers to learn how to program all these new FPGAs you have as part of your next processor, maybe. So I was lying a little bit because I'm doing Chisel teaching since some years. The difference is which course it is. I give several tutorials at conferences and some universities, and I'm teaching an advanced computer architecture course, which is an elective course at master level. This includes a final project and process and network on chips, this kind of stuff. And I'm introducing Chisel since 2015, I think, now, as part of this course. And from the material, from a one-day tutorial, it's about 4 hours I'm giving lectures, plus we have some experiments and some exercises, and people pick it up. 2016 to 2018, all projects have been in Chisel. So I convinced them. I don't enforce it to them. It's just an option. You learn a new language. If you insist on VHDL, please do so. Last year I had one who insisted in VHDL. Yes, but the rest is Chisel. What else? Several bachelor master projects. So students pick it up usually relatively fast. So kind of this one-day tutorial is enough to get started, which is 4 sessions. But they're mostly end of bachelor or master students. And interestingly, is that just as software engineering students. So at DTU, we have a lot of software engineering students. They find it kind of easier to get into the Chisel instead of VHDL. Maybe it feels closer to Java and more modern. And the hardware-oriented students are actually more conservative. They hesitate to learn something new. This is so scary. If they've really done a lot of VHDL and suddenly they get classes, objects, or whatever, or functional programming, even worse. So what do we do at DTU? So I'm actually at the computer science section, DTU Compute it's called, in a section, a department, and in a section where we actually find 4 or 5 teachers teaching hardware projects, which is at the computer engineering, as a computer science. But our students are electrical engineering, so there's a little bit of mismatch. So we're teaching 2 mandatory courses for electrical engineering, digital electronics 1 and 2, and it is in semester 1 and 2. So we used VHDL till last year. We did co-teach this course. Co-teaching is meaning 2 teachers. We're sharing our teaching load, which is an overhead, but we have also some kind of communication and getting some best practice. This year changes. I'm teaching digital electronics 2 alone. So I changed to Chisel to make it more interesting for me. And we have also master courses in hardware and computer architecture. If it's hardware course, it's all VHDL. So I'm now teaching 2nd semester students Chisel. They will then in the 5th, 6th semester go to the other course and say, I don't know VHDL, let's do it in Chisel. Let's see how my colleague will see this in 2 years. They don't like to switch to Chisel, this komisch scary thing. So my class, Spring 2020, starting next week. I should drop the extreme, but it's not their fault. It's in the 2nd semester. So they have no programming experience at all, except a few lines of semester. So they start coding, VHDL. So starting to learn Java in the same semester, I will do Chisel. So this will be a challenge. They have, of course, no command, most of them no command line experience. This is not the world. This is a Windows world. And how does Chisel fit into this context? This open source world where you do a lot of command line oriented typing, whatever. So what do they know? They had digital electronics 1 and 4, basic digital circuits, Boolean algebra. They use this classic no-map optimization per hand, and did a little bit of VHDL to write the small state machine at the end, running in an FPGA. So they haven't actually, they own an FPGA board. They have to buy it together with a book. They know, so to say, then how to use Xilinx Vivado, at least, and they usually have everything installed on their laptop. We have a lab with everything installed as well, but they come. So I have to tell them how to install Chisel or whatever is needed for Chisel. Yeah, Chisel under Windows. These are all Windows users. This is quite ignored in this world. I understand, but the world is very Windows affine. I mean, EDA tools are first Windows and then maybe under Linux. If you take the FPGA tools, they've always been very well supported under Windows. Under Linux, yes, this Red Hat version, so maybe. But actually, it's not so bad. Actually, Chisel is kind of Java JVM based, right? That runs just under Windows. You just need a little bit of documentation, what to install, and SPT is available, IntelliJ is available. So it's okay. So I downloaded Windows, which is now free, and in a virtual machine, and yes, it is doable. Good. What else do we need? Because we don't do command line, we want to have an easygoing IDE, IntelliJ. It's, I think, the first choice for Scala-based projects. It's very good for Chisel Scala, except the small issues with false syntax errors because of the Scala macros, I think. Starting a project, you basically just click on the build SPT and import it, and everything is set up after some minutes. And I have the chance actually to slowly introduce a little bit command line interface commands. Let's say opens a terminal within IntelliJ, doesn't look so scary, and type SPT blank run, this kind of stuff. So I will have a lab material per week, one Chisel project. So they're starting with different projects. All files given. So what else? What do we have available? We have a very nice boot camp running on Jupyter Notebook. It's nice to use, but I did not manage to get this running under Windows, not in an easy way, so that I can explain second semester students how to get this Scala plugin for the Jupyter Notebook running. It's bad. We started to adapt this original boot camp with some simple examples. Yes, and there's another one, the Chisel tutorial. It's also nice, simple examples, but it starts on the command line. And I'm wondering why this gets lost somewhere. I didn't find any reference on the Chisel website from this one anymore. Is this phased out in favor of the boot camp? Maybe. Good. So, of course, then you get your not invented here syndrome. I have to start my own stuff. So I'm having a GitHub repository for each week. It's a subfolder. With the first week, it just gets a tooling running. Take a Hello World example, which is in blinking LED, running through the Chisel process, running through Vivado, downloading FPGA, and then it blinks. Maybe it's a change of frequency, maybe not. This is the first week. And then we go on with simple circuits, and along with the simple circuits, we will do the Chisel code for it. And they working towards building a vending machine at the end of the semester. There's the final project on the Basis 3 Digiland board. They all bought it last semester. And then we have some assignments on coins and buttons and switches and manual clock or whatever. This display has to be multiplexed. This is hard for many students, getting this timing multiplexing right. So you're having a clock with 100 megahertz, and then you need to generate 1 kilohertz. When you start to learn how to write a multiplexer, this is tough. So vending machine is a 7-segment encoding and this display multiplexing, as I told you. Earlier, some people tried to do clock division, which is not very good way to do it. Then they do a simple state machine with data pass, adding coins and subtracting prices, whatever, and that running an FPGA. And of course, you have to write a report. Out of curiosity, I did this example myself. Of course, I know how the hardware works. I've seen this 1,000 times, no, not 1,000, but very often, so I know how to write it. It took me 2 hours. But half an hour actually was running under an error in Vivado saying it cannot generate bit files. I thought maybe my setup with the virtual machine running Ubuntu, accessing the file system on a Mac is the issue. But I missed a pin definition. And Vivado tells me cannot generate bit file. Oh, interesting. So I ended up in roughly 200 lines of code, which included a binary to BCD conversion because we can generate tables in Scala. That's nice. In the old days, I gave the students a Java program doing this table generation that's spilling out VHDL code. That's not how we did it before. In the VHDL version, not done by me, a little bit verbose, a little too many components, but it's roughly more than 200 lines of code without the BCD conversion. Good. Some more material. I wrote a small book. So we have a textbook on digital design with Chisel. Otherwise, how can we do? I mean, if you want to use it. So why a textbook with Chisel? Yes, because there should be one more digital design with Chisel. We need a simple start, no Scala, no Verilog. We still need to teach kind of circuits. I mean, some of you are as old as I am. So remember on 74 T-tail logic, you have a component, a counter, or something. And this is the abstraction of how hardware should be viewed as well, I think. I don't know. Maybe you can see it as a programming language. So I still think we need to learn to think at least in boxes. It doesn't have to be a single flip-flop. That hardware is structural and is running concurrent. Yes, this textbook is open access, open source, so to say. Helps to spread the word, I think. It's on GitHub, so I'm accepting typo fixes as pull requests, of course. Thanks to Yuda. Yes, thank you very much. There's a Chinese translation available. And yes, it's on. It's also on, you can also order a printout from Amazon for $11. It prints it for you. And actually, so Chisel is for HR hardware design, right? And on-demand printing and open access allows HR publishing. So I did the first edition end of August, doing some writing retreat. And then I thought, okay, let's do an update before I start class. So I uploaded a second edition 2 days ago to Amazon, the PDF, and clicked the button, and yesterday it was online already. So it takes 1 day to publish a book at Amazon. Good. My plan, keep it simple and not very Chisel-like, but using just basic constructs, maybe only register init saying each register has to be reset. Some Boolean equations with wire default. Wire default also helps you to not get your latch error, but this is actually nice with Chisel. When we had a lot of issues with latches in VHDL coding. People were writing latches and latches and latches. There's now errors, at least at elaboration time. Switch event statement, of course. And let's do simple testing and still debugging with waveforms. That's what we've always done. And just enjoy the linear syntax and the modern environment of IntelliJ. And I try to show them a lot of example code, maybe back-to-back with VHDL, so they don't complain at the end. They're learning only this research language, and they go in industry. They don't know anything used. But this is a wrong argument in a university. You have to learn principles and not languages. And if you can choose a language, you choose a nice one. I mean, we were teaching VHDL, and one hardware company is using Verilog, so you have to switch languages maybe anyway. Yeah, and if it involves nicely, I can add generators, parameters at the end of the semester if it works out. Good. I have people arguing in teaching programming, not in Java, but in Python, because of this boilerplate. People say, this is too much for a student. This is 2 lines of code. There's class, there's static, void main. I don't know. I don't think we should start programming with Python. So what can we do in Chisel? I think this is not so bad, the first one. It's a one-liner. But if we do the right way, how should we test? We should use Scala test and everything. Then the boilerplate becomes quite longish. Let's see. Good. In summary, Chisel worked okay for a master course. So I have several years of experience. It's nice. It's probably a little bit complex as really the first programming language to see. We'll see. Yes, it's a textbook now, and my plan is to stick to simple RTL-style constructs and avoiding Scala circuit generators for now. Thank you.
Got any questions, Martin?
What?
Yeah, okay, hold on.
So you're using VHDL. Is there a problem with the fact that Chisel generates Verilog for the students?
Yes, for one company. So I had a meeting with one company. They're using VHDL. They were merging with a German company using Verilog. So we're thinking about maybe moving to Chisel, but they don't like that Verilog is put out. But otherwise, I don't think this is an issue.
If Chisel becomes really popular, will you do a book signing?
Okay.
You heard it here first. Okay. Any other questions?
Or tips for next semester? I'm helping hand. Yeah.
Okay.
Edward.
All right, great. So
Edward.
let's take a, oh, sorry. I'm sorry.
Oh, for the purpose of giving the bootcamp to students, have you tried just pointing them to the Jupyter Hub online one? That one doesn't require any installation.
No, I have not. Because actually the plan was to make the bootcamp simpler, alternating it, dropping the Scala from the beginning, and then I would need to find a way to make it online. No, I didn't. Maybe next year, when you fix the problem.
Okay, good question, thanks. Anything else?